Today, through work supported by the Office of Naval Research, we are on the verge of a major breakthrough in predicting the intensity of storms, which will improve the accuracy of cyclone and hurricane prediction.
Typhoons, or tropical cyclones, in more general terms, are some of the most persistent and destructive weather phenomenon in the U.S. Pacific Command's area of responsibility.
Tropical storm formation is probably one of the remaining mysteries in tropical meteorology.
Although called different names, hurricanes, cyclones, and typhoons have similar characteristics. Hurricanes originate in the Atlantic, Eastern, and Central Pacific. The typhoon designation in the Northern Pacific west of the international dateline, and tropical cyclones originate in the South Pacific. No matter where they form, better understanding of the processes affecting storm intensity will provide major improvements in severe storm prediction.
Tropical storms, typhoons in particular, can wreak havoc for an operation planning on the ocean, where the winds will develop the seas, sometimes 50 feet waves. Ships just are not built to withstand for any length of time.
Understanding and predicting the size of a storm, its track, and its intensity are the goals for accurate modeling. To accomplish prediction goals, ONR is supporting research at the Naval Postgraduate School, the Naval Research Laboratory, and universities that is focused on improving a highly capable prediction model, the Coupled Ocean Atmosphere Mesoscale Prediction System, Coamps for tropical cyclones, or Coamps TC.
The way we do this is through very complex computer programs that essentially emulate the atmosphere by representing all the key processes that are present in tropical cyclones.
Being uncertain about a storm's intensity can potentially risk lives without adequate warning, while overestimating a storm's intensity can cause unnecessary evacuations or provide uncertainty for Navy and Air Force planning.
For 30 years, we've had improvement in hurricane track forecasts, and the errors have gotten smaller and smaller. But over that same period of time, we've seen very little increase in the accuracy of hurricane intensity forecasts. And you find that without a good, accurate forecast of the intensity, you have to go through a lot of preparations that are perhaps not necessary.
For every mile we can reduce that uncertainty, we bring a lot of maneuverability and a lot of cost savings to the operational Navy and Air Force.
Major research operations took place in 2008 and again in 2010 to discover more about the mysteries of storm intensity.
The objective of the 2008 and 2010 program was to go out with aircraft, with satellite data, and observe formation of a tropical cyclone, observe the intensification of a tropical cyclone, the structure change, and the motion. Without ONR support, none of this happens.
During these tests, researchers actually flew into the eye of the storm.
Total and complete darkness in the middle of the day, turbulence being tossed all over the place, rain coming down on the airplane so loud you can't hear a thing. And in a space of about, I'd say 15, 20 seconds, you go from that with a final jolt into the eye.
Both NRL's P-3s and Air Force Reserve C-130s provided opportunities for data gathering during each test.
One of the most unique aspects was we were able, with the C-130, the Hurricane Hunter aircraft, to fly right along the front of a storm, open the back end, and drop instruments into the ocean before the storm passed over those instruments.
Those instruments are known as AXBTs and dropsondes. AXBTs measure temperature profiles in the ocean. Dropsondes measure temperature, humidity, and wind profiles in the atmosphere. And this year, they will be dropped from unmanned Global Hawks during a NASA experiment, the Hurricane and Severe Storm Sentinel mission, or HS-3.
With an aircraft like the Global Hawk, we have 30-hour flights, and we can have 20 hours or more on station, or going all the way out to the Central or Eastern Atlantic, flying from the east coast of the U.S.
The Global Hawks are gathering key data that will be fed into the Coamps TC model.
So the Global Hawks give us an opportunity to look at a region of the atmosphere that has never been observed before around hurricanes, and that's the area between 30 and 60,000 feet.
Forecasters depend on accurate models.
Our forecasts will be shared with for example, the National Hurricane Center, and of course also the Joint Typhoon Warning Center as well.
The Joint Typhoon Warning Center, a United States Navy, United States Air Force joint center, is the focal point for issuing weather predictions in the Pacific.
So the work that we do here at JTWC provides forecast information to installation commanders and other warfighters that they may take protective actions to prevent damage that could be associated with tropical cyclone impacts.
ONR support will give forecasters a tremendous advantage with Coamps TC.
So what that will give the Joint Typhoon Warning Center, a tool that no one else in the world has.
Countries in the tropics all over the world will benefit from more accurate predictions.
If we can do anything to give them a better warning, to give them more time to prepare, that to me is the great benefit of all this research that we do.
The Coamps TC model has already shown a great deal of success in tropical storm predictions.
Our model was able to forecast that 28 out of the 52 weeks there would be no storms and there were no storms.
It allows the operator on the other end that has to deploy those forces into the future look and say, we have a superior forecast, we have superior information, and we can go forward with the operation.
So ultimately, if we can understand hurricanes better and understand some of the physical processes that are going on, and then model them with models like Coamps TC, I think we can make better predictions for the Navy, which is especially important both in the Atlantic and in the Westpac for fleet safety.